Welcome to class tonight. I do hope that you all are doing very well. Last night and today in class we worked on adding mixed numbers. Tonight we're going to be switching things just a little bit by talking about subtracting mixed numbers. Now the nice thing is, ladies and gentlemen, that adding and subtracting mixed numbers are actually very similar. We're going to be using much of the same skills, but obviously we'll be subtracting. Now let's go ahead and get started with what should be by now a pretty easy part. Now you see two mixed numbers on the board here, and then you see right here this box, and this box should seem pretty familiar. Last night's video had a very similar box talking about addition, but you'll notice one very important difference. I actually changed the order of which to do first. I actually said first we should be subtracting the fractions, and then we subtract the whole number. So let's go and jump right in and try this out. So the first one is going to be 3 3/4, and the next one that's going to be 2 5/8. Alright, so I have 3 3/4 minus 2 5/8. So now the way this is going to work, remember, we cannot subtract, or we cannot add, or we cannot do anything like that until we have a common denominator. So this is one very similar part to addition. We have to have a common denominator first. So let's go ahead and do that. 4 and 8, and list out my factors. So it's 4, that's, ooh, there we go. That's my common denominator. So I have 8 as my common denominator. So the nice thing is, I don't have to change that one at all, but I do need to change this. So it's going to be 3/4 times something is going to get to 8ths. So let's see, 4 times 2 equals 8. 3 times 2, because whatever I do to the bottom, I have to do to the top. 3 times 2 then is going to be 6. So I'd rewrite this like this. 3 6/8 minus 2 5/8. Now I'm going to subtract my fraction first. So 6/8 minus 5/8 is going to equal, well, 1/8. That's simple. And then I subtract my whole numbers. 3 minus 2 is going to leave me with 1. And so there you have a very simple problem where we subtract, get common denominators, and then I subtract my fractions, my whole numbers, and combine. So the answer to this problem then is going to be 1 1/8. So that is the easy part. Now let's get to the, we'll call it a little more difficult part, but it really should not be. Now you see on the board here a mixed number. Now normally I would call this, so normally I would say that's a whole, so 3 wholes, and then 1, 2, 3, 4, 5/8. So normally I would call that 3 5/8. But, ladies and gentlemen, can't we also say something like this? Can I say 2 wholes, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I can say that. So technically, I could say that this number right there could also equal 2 13/8. Or 13/8. Then you say, Mr. Hurst, why on earth would you want to do something like that? Why on earth would I want to make an improper fraction out of my numbers? Well, I'll tell you, it's going to become very important here in just a minute. But I want to show you that you can. Now, I'm going to erase this. I'm going to try it again. So I could technically name this 2 13/8. I could also name it like this. I could go 1 whole, and then 8 plus 8 is 16, 17, 18, 19, 20, 21. So I could say that this also equals 1 21/8. Now, this gets to specifically how the idea of what we think about a number. So this, ladies and gentlemen, 3 5/8, that is what we call the simplest form. But these fraction pies represent something that's incredibly important. They represent what we would call actually several different numbers. Because as I just showed you, I could write this whole thing as 2 13/18. I could write it as 1 21/8. I could write it, technically, I could write it as, so it's going to be 20, that's 8 plus 8 plus 8 is going to be 24, 25, 26, 27, 28, 29. I could technically write this as 29 eighths. It all represents the exact same thing. So while these numbers all look very different, you'll notice a couple things. First of all, they all have a denominator of 8. You'll notice that. And they all represent these. If I count up all these individual pieces, I would get 29 eighths. So I'm pausing here, and you say, Mr. Harris, it doesn't seem like this makes connects with the lesson. Well, I assure you it does, and you'll see that in just a minute. But I wanted to take some time to remind, or should be reminding you, that I can write a number, I can write this right here in many different ways. Now, let me go ahead and tell you why this is a big deal. So I have a problem on the board. The problem we would see, or what we would say, is that 7, 1, 2, 3, 4, 5, 6, 7, minus 2 and 5/8. I have 7 wholes over here, and I have 2 and 5/8 over here. Now, you say, wait a second, Mr. Hurst, there's no fraction over here. So how can I subtract a fraction if I don't have a fraction over here? Well, that seems like a problem. Until, I go back here on purpose, until you start thinking about numbers like this. I can name any fraction very similar. I can name any fraction, obviously it needs to be the same number, but I can name my fraction several different things. So what if we were to think about it like this? What if I were to take one of these pies and cut it into 8 pieces? I know it's pretty bad, but that's 8 pieces. What if I were to cut that into 8 pieces? And so I would say that is 8 eighths. I could do that because it's the exact same thing over here, so you can compare this to this. Well, they look obviously very different. I can still cut it and name it something else. I'm not changing much at all. I'm just changing the way the number, or the way the fraction looks. So this way, so I would rename my fraction. So instead of 7, I could say 6 and 8/8. So I've just completely changed how I name my fraction. Now the nice thing is, this is all okay. This is, I'm not changing anything here, because you say 6 plus 8/8 is the exact same thing as 7. I didn't take away or move any of these circles right here. I didn't take away or move them at all. I kept them the same. But I'm just showing you I can take my number, my whole number, and change it so that I can actually use it. And so now, ladies and gentlemen, let me show you how we can do this. So now instead of saying 7 minus 2 and 5/8, I would say 6 and 8/8 minus 2 and 5/8. Well, now I can subtract. Now it's very easy to subtract, because 8/8 minus 5/8 is going to be 3/8, and 6 minus 2 is going to equal 4. And so there, I have taken a somewhat scary mixed number. So instead of saying 7 minus 2, actually I'm going to write it the other way, 7 minus 2 and 5/8, instead of saying that, I can actually write it like this, and it makes a lot of sense. Now there's one other way I wanted to show you, and this is another way I think that actually will help a lot of students out, and I recently learned this way. Then the other way we can think about it, so we can think about it like this, just taking 1 and changing it to eighths, or we could change both sides to mixed numbers, or sorry, to improper fractions. If we take both and make them improper fractions, it's actually very easy to subtract. Let me show you how this will work. So if I'm going to make everything eighths, because my denominator is 8 here, so it's going to be 8, 8, 8, 8, 8, 8, and then 8. So 1, 2, 3, 4, 5, 6, 7. So it's going to be 56 eighths. Okay? I just took all of my wholes, all right here, and I made them eighths. And so that's 56 eighths. And over here, I take my 2 times 8, that's going to be 16, 17, 18, 19, 20, 21. See what I just did? I took my numbers, my mixed numbers and my whole numbers, and made them improper fractions. Now I can subtract very easily, because 56 minus 8, or 56 minus 21, that is going to be, so that's going to be 35 eighths. Now you see how that was actually, I think it may actually be a little bit even easier than that. This, if you just make them improper fractions, it's very, very easy. Now obviously, ladies and gentlemen, figured you were probably going to remember this. I cannot leave my number as I can't leave it as 85 eighths, so I need to make it a mixed number. So it's going to be 4. That's going to be 3. So look at that. Oh, why did I do that? That's weird. I don't want to confuse you there. There we go. So my final answer is going to be 4 and 3/8. So you see, I actually did it two different ways. I converted one whole into a fraction, or I could just do the whole thing and make them all an improper fraction. So those are the two different ways we can do it. And I drew these lines to maybe help you distinguish between the two ways. It would be very wise to actually go back and maybe watch this portion again and see how I do this. All right, we have one last question. This is, as we always do, the application question. So the question is, in 1 hour, a bee can fly 5 2/3 miles. That sounds important. And a moth can fly 11 1/6 miles. How much farther can the moth fly in 1 hour? Now, how much farther? That's code for subtract. So I have my problem there, 11 1/6 minus 5 2/3. So my first order of business, just like always, just like when we always go back there, is to combine or to subtract the fractions. Now remember, I cannot do this until I have a common denominator. So let's go ahead and find that first. It should all be review. 6 and 3, so it's going to be 6. Ooh. So that's my common denominator. So let's go ahead and take 2/3. 3 times 2 equals 6. 2 times 2 equals 4. So I'm going to rename this as, and let's do it over here. So 11 1/6 minus 5 4/6. Okay, so I've renamed my fraction. So now I can subtract. But wait a second. I have 1/6 here, and I have 4/6 there. I can't take away 4/6 if I only have 1/6. So going back here, we're going to have to rename something. Now, you could do it like this, where you only rename one of the fraction, or one of the pies, but here's my suggestion. Let's do the second version. That's what I'm going to try. We're going to make everything into an improper fraction, and then subtract. So we take this to an improper fraction. It's going to look like this. Multiply, and then add. Okay? So 11 times 6 is 66. 67 sixths. Minus, multiply, that's going to be 30. 30 minus 30 plus 4 is going to be 34 sixths. And bam! Just like that, I can subtract very easily. So that's going to be 33 sixths. Now remember, we cannot leave it in an improper fraction. So let's go ahead and change that very quickly. So I have 33 inside the box, 6 outside the box. So it's going to be 5. 5 3/6, and remember, we always reduce, and 3/6 becomes 1/2. So my answer is going to be 5 1/2 after I reduce 3/6. So ladies and gentlemen, you see how very easy that was? When I converted everything into an improper fraction, it made it very, very simple to subtract.
I then take that improper fraction, make it back into a mixed number, and bam, just like that, I have my answer. So my answer is going to be 5 1/2 hours. All right, ladies and gentlemen, as I mentioned earlier, it'd be very wise to go back and review this lesson, even back up a little bit and make sure you're understanding what we're talking about and watch this again. The biggest part is knowing how to rename fractions. So going back here, so this portion right there, that is the most important part. You can do it one of those two ways, but you need to be able to rename a fraction into something else. All right, so ladies and gentlemen, so that is the lesson. Your homework tonight is going to be page 192, 193, 7 through 15. Once again, page 192 and 193, 7 through 15. Even. Or 7 through 15 odd. Sorry about that. All right, have a great night.